Ms. Davis also said that you guys wanted to see questions 4.5 through 4.7 from the packet. So let's try at least to get a couple of these done. I probably will do one per video. 4.5. The angle of refraction of a ray of light traveling through an ice cube is 31 degrees. Find the angle of incidence. So we know the angle of refraction. The refraction angle is 31, and it is ice, which is water, okay? But we'll take a look at that in just a second. Find the angle of incidence, assuming the incident ray was traveling in air. So we were starting in air, we went into an ice cube, and this was my angle of refraction. Before I write a given and find list, okay, before I list all of my information, let's draw a picture. I'm going to draw it just like the Snell's Law Lab, okay? So here's my little picture right here. Here's my normal. Remember, it's that dashed line that represents a fake measuring, frame of reference right here. We have air, and we know air is N is equal to 1. We're using that a lot. We have the light ray coming in, okay? This is my angle of incidence. This is my unknown. I don't know what that is, okay? And then when it hits the ice cube, it's going to bend a little bit towards the normal. And I know my angle of incidence is my unknown, my angle of refraction, theta sub 2. They did give that to me, and they said that was 31 degrees. This is ice. And over here on your packet, here's ice. 1.31. So we're going to use that as our index of refraction for ice. 1.31. Okay, now that I have an image, this is helpful. This is what I'm looking for. This is my unknown, so question mark right there. I'm going to say that theta sub 2, right, because this is my second angle, is 31 degrees. N1 is air, so it's just 1. N2 is ice, that's 1.31. And I'm trying to find theta sub 1. Well, we're still using Snell's law. N sub 1 is times the sine of theta sub 1 is equal to N sub 2 times the sine of theta sub 2. Let's plug in what we know. N sub 1 is 1. Sine of theta sub 1, well, we don't know what theta sub 1 is, so we're going to leave that there. That's our variable we're looking for. N sub 2 was ice, 1.31. Sine of theta sub 2, that was 31 degrees. Okay, so I'm looking for theta sub 1, and it's stuck inside the sine function. By the way, does this 1 matter? No. No. It's not going to change anything. If we divide by 1 over here, nothing really is going to happen. So I'm just going to kind of ignore this number 1. That's ignorable, okay? So really the equation is sine of theta sub 1 is equal to all of this. Well, let's go ahead and let's multiply these two things. 1.31 times the sine of 31. Okay, here we go. 1.31 times the sine of 31. All right, so this over here, I'm just simplifying this, is 0.67. I'm going to round it to 0.67. And in order to solve for theta, remember I told you have to do the inverse sign. You have to raise it to that -1 power with sine. And what you do to one side, you have to do to both sides. Inverse sine. Well, what does that look like on the calculator? We're going to take this number. We're going to inverse sine it. We're going to click that shift button, and we're going to click the sine button because right above it in gold, it says sine to the -1 power. So shift, sine, and then what I'm going to do is I'm going to click this answer button, and it's just going to drag my answer, 0.674, blah, blah, blah. It's going to drag it in there, and then I'm going to click enter. And there's my answer, 42.43. That's what I'll round it to, 42.43 degrees. That is my angle of incidence. You're solving it the exact same way you would have if we were looking for angle of refraction. It just happens to be on the left side of the equal sign instead of the right side. So we're still using the inverse sign. We're still simplifying everything. But I think when you draw a picture to set it up, it makes it so much easier to see what you're doing. And then you also use your give and find list. Hopefully that helps.